Hello everybody and welcome to this video today in our YouTube channel. In this video we shall be looking at the secret weapons that you can use to score 100 over 100 in the physics practicals. So guys, stay tuned and watch the video from start to finish, because at the end of this video you shall be able to walk into that GC hall for physics practicals and you grab all the marks, guys. So friends, don't forget to like this video, share it out with your friends so that they can also have access to good contents like this that is going to help them so well in their own examination. Thank you very much, guys. And please, for a quick reminder, if you're new to our channel, friends, don't forget to hit that subscribe button looking at you and the bell icon to get notified each time we upload new videos. And don't forget to like the video because it does motivate me to keep producing more and more contents for you. Thank you very much, guys, and let's dive straight into our video today. Okay friends, please, before we start guys, I want us to look at the structure of the A-level physics practicals, guys. Let's just look at it. Let's just take about 10 seconds or less to look at the structure of A-level physics practicals. So guys, as you all know, there are two questions in the physics practical, guys. We have question 1, which is mainstream, and we have question 2, which is stations, guys. And we should know that there are 4 stations and 1 mainstream. Okay, there are 4 stations and 1 mainstream. So as you're entering that hall, you should expect to see the first question being the mainstream, which involve experiments, which you have to set up and carry out experiments and draw conclusions. Then under the stations now, you have to also set up and carry out your experiments. But the difference is that under this mainstream, you shall be instructed on what to do. Okay, they shall tell you everything to do, but for these stations they won't tell you anything. They'll just give you the equipments and tell you what to determine. You are the one to devise your procedures and report the experiments. So friends, now I'm very much sure that you now know the structure of the physics paper 3 practicals, right? Good. So now let's dive straight into the major reason for our video today. Let's look at those secret weapons that you can use to score all the marks in the physics paper 3. So guys, don't forget to like the video. As I said, please like the video so that is going to help others locate our content. So let's dive straight into it, friends. Okay, great friends, let's start by looking at the general points to always take note in the physics practical, friends. Let's look at the general points. Friends, let's start by analyzing the laboratory manuals, because most students always neglect the laboratory manuals, not knowing that they are killing their own self. So guys, you should always make sure that you have at least 40 sign exercises on your physics manual. Okay, always make sure that you have at least 40 such that you can be awarded the marks for the manuals. Great. Then guys, you should always learn how to read all your measuring instruments very well, because this is what can kill you in that hall if you don't know how to read instruments so well, like the multimeter, the micrometer, screw gauge, and so on and so forth. Guys, you know how to read them so well. If you cannot read them, guys, check out my video. I have a video on how to read those instruments, guys. Check it out, check that video out. It's going to help you so well, guys. Then friends, you should also know the theory part of physics to your fingertips, guys. Is super important. Okay, you have to know the theory part so well. It's super important. Then guys, know the standard values used in physics, such as the values for the values for the acceleration to gravity, the refractive index of air, water, and glass, and so on and so forth. Guys, you should know these standard values because they're going to help us a lot. They'll help us a lot in the laboratory. Okay, they'll help us so well. They are super important, guys. They are super important. Good. So friends, now let's look at the next phase. So friends, you should know the laws and principles in physics and how to apply them, friends. Is super important. For instance, guys, you should know the law of moments. That's the principle of moments, and so on and so forth, guys. And guys, the important ones used in physics practicals often include, let's see if we can name the most important laws that are so important in the physics practical, guys. In the first place, we have the laws of reflection and Snell's law. We have the principle of moments. We have Hooke's law. We have the law of flotation. We have the laws of electromagnetic induction, Ohm's law, and so on and so forth, guys. They are super important. Okay, very important. You should know the laws of reflection because they can ask you to investigate the laws of reflection. If you already know the laws. Oops guys, this was supposed to be M, okay, Snell's law. So friends, if you already know the laws of physics, if you already know these laws and you're asked to verify them, it becomes so easy, right? Because you already know the laws, you can just simply design your experiment and report it. Okay, good. Then the principle of moment, guys, I can guarantee you that the year in which I was writing my physics practicals, the principle of moment came. Okay, the principle of moment came. We've been asked to determine the weight of a uniform bar, and we had to use moment. The question did not tell us moment, but you had to use moment. And Hooke's law as well came, but we were not told that it is Hooke's law. The law of flotation as well came, but we weren't told that. That's why I'm saying that you should know these laws so well and how to apply them. They are super important, guys. So friends, you should never take down values using a pencil unless you're drawing a diagram or a graph. Friends, this is super important because the moment the examiner see you writing values using a pencil, the examiner assumes that you don't know anything. The examiner is just going to cross your work and give you a 0. Okay, so guys, take note. Never write down values using a pencil. Write them using pens. If you make errors, cancel them neatly and write the correct thing. Okay, that's great. That's great. And friends, also, you can record your values on a rough sheet of paper. That is, if you have, before you then transfer to your exam sheet. But that is going to waste time, guys. Keep in mind that the paper 3 physics is designed to be answered for 2 hours 30 minutes, so time will never be on your side, guys. So always try to go straight to the point. Now guys, let's move on to the main body of the video, guys, the main objective of our video today. Good. So friends, now let's start. Excellent, guys, we are in question 1. That's the mainstream. That's great. So friends, you should never start. This mainstream is super important, guys. It's very important, such that it deserves some stars, right? Good. It does deserve some stars, friends, because the mainstream is super important. It takes 50% of paper 3 physics. 50%, guys. It's super important. You should never neglect the mainstream. That's the first question you see, guys. If you don't pass it, your chances of passing physics are very slim, but not as slim as 0% of you passing. Okay, but they are very slim. If you don't take care, you might fail. If you work hard again, you're going to pass with good grades. But friends, like I said, the main objective of this video is for you to score 100 over 100. Okay, 100 on 100. So friends, all what I'll be highlighting throughout this video, if you can master them so well, therefore the chance of you scoring 100 on 100 is still 100 on 100. Great. Great, guys. All right, friends, let's start. Guys, you should never start doing experiments unless you have read at least twice, guys. Never start doing any experiment on this mainstream unless you've read and understood so well, guys, so well. Don't bother if your friends have started already, guys. They will start and they will hook at some point in time. I can guarantee you that. I can guarantee you. But take your time, guys. When the examiner says start, right, look for a chair. If there's a chair in the examination hall, you sit down, take your paper and read it so well. Read it, understand it first before you start writing, guys. It's super important. It's very important. This point is very important, guys. Always try to understand, read everything from start till finish. Understand everything, guys. Understand everything before you start writing, before you even put your pen on your paper. Great, friends. It's super important. It's very important. It has helped me so well. Then friends, this is what so many students don't know, friends. This is what so many students don't know. If you've read the mainstream and you try to do it and it seems difficult and you see that you do not have time to redo the process all over, guys, you can call on the attention of the examiner to set it up for you and he will do it. Okay, he or she will do it. That is, if you've struggled to set it up and you do not have time and you're still unable to do it while time is going, friends, call on the examiner, call on his or her attention to set it up for you. Okay, the examiner will set it up for you, then you can just do the rest of the experiment and collect your values. Okay, but the disadvantage of doing so is that the examiner is going to write something on your paper that will be taken to the examination board, such that some amount of marks are going to be lost. Okay, about 1/4 of the marks, or maybe 1/3 of the marks, shall not be awarded to you, but that will not make you not to score the 100%. So guys, work by our rules and score everything. Make sure you testify after you scored it, guys. Make sure you testify to me, because these are the rules. These are the points that it took me about 2 weeks if I could gather all of them and make them like this in a video. So friends, it took me a lot of time to bring forth all these points to explain them like this. So friends, don't forget to give this video a like. Don't forget to press the like button, because it does motivate me quite enough to keep producing more content, guys. Thank you as you like the video and share out the video. Good. So friends, this point now is super important, guys. Super important, guys. Wait and note this point so well. It's super important. That's why it deserves stars, guys. It's super important, very important, guys. Very important until it deserves another star. Good. So friends, be mindful of the precision of all the instruments you're using, friends. Be mindful of their precisions. For instance, friends, a metal ruler can measure distances toward 1 decimal places. Okay, 1 decimal places. So even if you measure a certain distance and it is exactly about 2 centimeters, okay, you must write it as 2.0, because if you write 2 centimeters, no doubt, friends, examiners will mark it wrong. There is no doubt about that. Okay, there is no doubt about that. Don't mark it wrong. And you should know that the metal rule, like I said initially, measures distances to 1 decimal place, okay, and in centimeters, right? It measures them to 1 decimal place and in centimeters. Now the vernier caliper, friends, measures distances to 2 decimal places, right, and in centimeters. It's super important, friends, for you to know. It measures to 2 decimal places and in centimeters, whereas the micrometer screw gauge measures very small distances in what, guys? In millimeters and in 2 decimal places. Take note, friends. It's super important. It's super important. We have millimeters as to 2 decimal places as the vernier caliper, but the difference is that the micrometer measures distances in millimeters, while the vernier caliper measures distances in centimeters. Good. So friends, be very mindful. For instance, if you measure the distance of let's say the diameter of a piece of chalk, right, and let's say the diameter is exactly 5 millimeters. If you say 5 millimeters, no doubt you are going to fail it. No doubt, guys. There's no negotiation on that. You must write 5.00 millimeters. Super important, guys. It's very important. Very important. The physics practical takes note of it. Okay, they take special note of it. The moment you do something that is not what you're supposed to do, they simply just cross it and give you a 0. Good. So friends, take notes so you can score all your marks. And friends, very important, friends, very important, the protractor, which is being used to measure angles, you measure angles using that protractor to the nearest whole number. Okay, the protractor cannot even measure decimal angles. Okay, it cannot measure decimal angles, so you always measure them and round them off to the nearest whole number. For instance, if you're, let's just say, an experiment that has to do with optics, you have to measure the refractive index of a glass block, and somebody sees, an examiner sees you writing 24 point anything degrees. No doubt, friends, they just crossed and give you a 0. They just cross that value, just mark the value wrong. Go on, guys, no negotiation. Okay, so friends, be mindful of that. And friends, as for a thermometer, okay, a thermometer measures temperature, but there are some thermometers that can measure temperatures to 1 decimal places, but it's mostly common to the chemistry practicals. Okay, very common to the chemistry practical where it measures temperature to 1 decimal places. But most thermometers that we have now around, they can only measure temperatures to the nearest whole number. Okay, to the nearest whole number, most of them. So friends, let's be mindful of that. But each time you take an instrument in the physics laboratory, always try to look at its precision. Okay, is super important, friends. Super important. You can measure a very you can measure something and your answer is super correct, but if you didn't respect the precision, you score a 0 in that particular question. Good. I hope that was useful, friends. If it was useful for you and you've downloaded the video, friends, just come back and give the video a thumbs up, like the video, because that is your own gift to me. It actually tells me that you found this content useful. Thank you very much, guys. So now, friends, let's move on to the next phase of this our video. Okay, friends, for experiments that require you to take oscillations, always take them twice and get the average. This is very, very important, friends. Very, very important. Always experiments that require oscillations, such as the experiment to determine the value of G, that is the oscillation due to gravity, friends, where you're to do it using oscillations, using the super pendulum method, guys. You must take the time twice. Okay, take the time twice and get the average of the 2 times. It's super important, guys. Super important. Then, friends, on the always record your values as you see them on the then process them later on, guys. It's super important. For instance, if you are to record your time in minutes, let's assume that you're doing an experiment that has to do with heat. Okay, that tries to measure the rate at which heat flows along a conductor, right? Because initially it takes a very short time for the heat to travel through a distance, but as time goes on, now it now starts to consume more time. So, friends, in such a case, friends, you are to take your time in minutes. Okay, take your time in minutes, record them on your table in minutes, plot your graph in minutes. But when doing your calculations, that's when you can convert them to standard units. Okay, standard units. So always plot your graphs using the values you have, because if you want to convert to seconds, guys, they're going to be so big, and you'll be unable to make a good scale for your graph. Good. So, friends, I hope that was useful. And friends, like I said, you must not convert all of them to standard units. You can plot your graph, but when doing calculations now, friends, when doing your calculations, that is when you must have to convert all the quantities to their standard units before doing your calculations. Okay, it's super important, guys. Super important. Good. So I think everything is here. Everything is here, friends. So everything I've said is here. And guys, you should never use plotted points to calculate the slope of your graph. Never, guys. Never use plotted points to calculate the slope of your graph, because the moment the examiner says you even using one plotted point, guys, the examiner just crosses it and you score a 0 at the end of the day. So be very, very careful, friends, not to use plotted points. Great. Then, friends, always know that for experiments that involve the rate of heat transfer along, always expect the graph to be a curve. Okay, always expect the graph to be a curve. Experiments that have to do with heat, guys, that have to do with heat. For instance, you heating a metal or heating water and so on and so forth, guys, or any substance, guys, always expect to see always expect to see a curve. Okay, always expect to see your graph being a curve. Another hint that can help you to know that the graph is a curve is if you're being asked to calculate the slope at a particular point. Okay, that's when you know the graph is going to be a curve. And in such a case, guys, you simply take a ruler and draw a straight line at that point, then bring forth a tangent triangle whose hypotenuse touches that point at one unique point. Okay, from then on you can now get values, you can now get points and calculate the slope of your graph. Good, friends, I hope that was useful. And let's look at those for the stations, guys. Let's look at for the station. Okay, friends, for the station, guys, you should make sure that you identify the area in which that topic is coming from, because each station has a particular topic in physics where it is coming from. Once you're able to identify that topic where it is coming from, guys, it gives you an edge or that particular station to pass everything. Okay, good. So always try to identify it. For instance, if I'm being asked to measure the internal resistance of a cell, I know that it's coming from where, guys? It's coming from electricity. Okay, specifically I'm to use something that has to do with Ohm's law or Kirchhoff's law and so on. Okay, so guys, it's super important to identify the topic where that station is coming from. Good. And guys, always take your time to read very well. Always take your time, guys, to read that station very well. Make your sketch before you start answering the question. Okay, and make sure that when drawing your diagrams, always include all the quantities you are to measure. Okay, include all quantities you're to measure, because if the examiner does not see the quantities you're measuring, he or she will not give you the marks, guys. He won't give you the marks if you don't indicate on the diagram the quantities you're to measure. The examiner will not give you. Great. So friends, and under the procedure, to write the procedures, make sure you report all of them in past tense. Okay, make sure, because one mistake that most students will do is that they'll be instructing the examiner on what to do. They'll simply tell him that, like for instance, the examiner might be asking him to devise an experiment to determine the refractive index of a glass block or of water. They'll simply tell or of a glass block, right? What they'll do is that they'll simply tell the examiner that take a block of mass provided, make outlines on it on a clean A4 paper, and so on and so forth. They are instructing the examiner. The examiner will mark it wrong. Okay, report in past tense that an outline of the block was made on a clean paper, and a rail of that was, and so on and so forth, guys, and optical pins were being used and aligned such that the rays were straight, and so on and so forth, guys. Okay, good. So you have to report them in past tense. Good. Then friends, you must have to indicate how you measure each quantities you have measured. Okay, you must have to indicate how you've measured the quantities. Always tell them, like for instance, if you're measuring current, you tell them that you're measuring the current using what, the ammeter. If you're measuring voltage, tell them that you're measuring it using the voltmeter. But in real life, guys, in real life, you'll be using the multimeter to measure those two values, but you won't say multimeter. Okay, because the multimeter can measure current, resistance, EMF, or voltage as well. Okay, but if you're using the multimeter to measure voltage, always call it the voltmeter. If you're using it to measure current, you call it the ammeter, and so on and so forth. Okay, if it's resistance, call it the ohm meter. Good. So friends, that's super important, very very important, guys. Then for the inferences, because you must have a section where you are going to write the inferences, you must have to tell the examiner the main idea behind your conclusion. Okay, the inference is sometimes known as the physics of the problem. Okay, it's known as the physics of the problem. You must have to tell them the physics that has led you to be able to solve that same question. Okay, you must let them the physics. You must tell them the physics of that problem that has helped you to answer it conveniently. Good. And friends, this one is very very important, as most students don't even know. Not all experiments, guys, stations specifically, not all of them that you should actually carry them out. Not all of them want you to actually carry them. Okay, not all. Some of them are just, some of them you can actually use your theory. You can actually use just the physics you know to answer them. Okay, you must not carry them out. That's what I said initially. I started by saying initially that you should know the theory part of physics so well. You should know it so well. Know the laws so well. Like for instance, you can be like when I was writing my own exam, my own physics practical, they gave us a nail, they gave us a cable, they gave us magnets, right? And they asked us to connect the circuit. They asked us to make turns around the nail such that we could produce a solenoid, and they gave us a magnet, and they gave us a multimeter. Oh, that is an ammeter, right? And they asked us to produce current and measure the value of the current. Good. So friends, in that experiment, I never carried out, but I scored all the marks. I never carried the experiment out, while others who carried out and did not even do it well, they didn't even have the marks. So friends, what you need to do is that once you've been given all those things, what should come to mind is that they want you to just simply verify the Faraday's law. That's just what they have to tell you, guys. Because after rubbing the wire onto the nail, you're going to produce turns, right? You can start to be a solenoid, and once you've connected everything to the ammeter, now you simply take the magnet now and move it over and over through the solenoid, such that the field lines shall be cut. And we know from Faraday's law that each time electric field lines are cut, an EMF is induced, right? That induced EMF now therefore helps to drive a certain amount of current that is going to flow. But you must know that the amount of current is going to be very, very small, so you must set the micrometer screw gauge, you must set the multimeter to read only currents in micro, okay, so that you're going to see values. So I didn't carry it out, guys. Since I knew the theory, I just reported it good, and it was perfect. Okay, it was perfect. You can still do that. It's perfect. All you need to know is to know the physics so well. Wait. So friends, I think that's all about these are the most important points, guys, that can help you to give you the 100 on over 100 of the physics practical, guys. So I think these are all the points, guys. Don't forget to like the video, subscribe to our channel. So friends, now just turn on the notification bell to get notified, guys, each time we upload new videos. And friends, watch out for the top frequently asked questions in the physics practicals and their well explained solution coming up very soon, guys. Just when you subscribe to the channel, you're going to have access to watch that video. Thank you very much, guys. Stay safe and good luck as you prepare for your exam. Like I said, I am going to be uploading this content I just displayed here on screen, so you can't afford to miss, right? Just subscribe to the channel and press the bell icon so that you get notified whenever I upload the video. Thank you very much, guys, and stay safe. See you and have a blessed day.